So we have this question where we have this atom that I'm calling big M, and it splits into two smaller helium atoms, which I'm calling little m. And when they split, it releases a certain amount of energy. And if the atom is originally at rest before it splits, it wants us to find the kinetic energies of the two helium atoms and the speed. So the first thing we do is we use momentum. That's this part. Momentum's conserved because it's kind of like an explosion problem. And because initially the atom is at rest, and because the two masses are equal, it mentions two atoms of the same mass, we can divide out by the mass, and we find that V1 is just negative V2. And that makes sense. The particles are just going to go their other way. Now, kinetic energy is equal to 1/2 mass times velocity squared. So if the total energy released is the 92.9 kilo electron volts, each one is going to give that off. Each atom is contributing to half of that because their masses are the same and their velocities are just in the different directions, and that's not going to matter when we square it because that'll take care of the negative. That's just the negative. This negative just tells us the direction. Okay, so all we have to do here is we have 92.2 times 10 to the third. So that's just converting to 1 electron volt. And what we want to do there is divide by 2, because each atom is equally representing that. And if we do that, 92, you should get 4.61 times 10 to the 4th electron volts. And I guess that's technically the answer. And if you wanted to convert to joules, the key to remember is 1 electron volt is 1.6 times 10 to the negative 19 joules. So if you wanted this in joules, then you just say 1 electron volt is 1.602 times 10 to the negative 19 joules. And the electron volts drop, and you'll get the answer in joules that way. Now, if you want to find the speed of any of these particular, of one of the particles, well, they both have the same speed, just different direction, we can say that kinetic energy is 1/2 its mass times velocity squared. But now we know what, let me actually plug this in because I need that number. 4.61 times 10 to the 4th times 1.602 times 10 to the negative 19th, and 7.39 times 10 to the negative 15 joules. And the reason why we're converting that is because we're going to plug that into here to solve for our velocity. So 2 times the kinetic energy divided by the mass, square root, is your speed. But from the previous part, we know what the kinetic energy is. We solved for it. So all we have to really do is plug it in. So velocity is the square root of 2 times 7.38, right? 9 times 10 to the negative 15 joules. We need the units to be in joules here because we want our speed to be in meters per second. Divided by the mass, What's the mass is 4u. I don't know that off the top of my head, so let's just see. U to kilograms. Okay. So it's according to Google, 6.642 times 10 to the negative 27 kilograms, which is the units we want here. Okay. So now we just have to plug all these values in. And I'm sorry if I said something wrong, like a lot of times I'll say one thing and I'll write out something else. That happens a lot, actually. So I end up getting velocity is 1491721.611 meters per second, or let's see, 1, 2, 3, 4, 5. So pretty fast, but that's more or less how we go. So just to mention, we use, I guess we really didn't need to do momentum. I don't know what I was doing here, but I guess it just shows that they go in the same direction. Anyways, we find the kinetic energy by using the equation and recognizing that both atoms will contribute to half of the 92.2 because they're identical. The thing that momentum did show us is that they're going at the same speed, and it mentions their masses are the same, and those are the only factors that matter in kinetic energy. So they're both contributing equally to the kinetic energy. So we can easily find the kinetic energy of each atom, and then just using a conversion factor get it in joules. And then using that same equation, we can solve for velocity here to get speed. So I hope that helped a little bit. I hope that makes a little bit more sense now. And if not, then maybe I can find a better way of explaining.